Hi guys, let's start our next exercise in the chapter solids. In the first exercise we talked about volume, which was length into breadth into height, and the surface area, which was the total surface area, which was 2 times LB plus LH plus BH. And then we talked about lateral surface area, which means the 4 walls, and this in this case was 2 times L plus B into H. This was for a cuboid. For a cube, this became L cube, this became 6L square, and this became 4L square. Perfect. Let's look at the second exercise where we talk about cross section. Now, what exactly is cross section? Cross section is basically the face that you get to see when you cut on a solid perpendicular to its length. So if you look at this example here, this is a rectangular cuboid, and when I cut it perpendicularly along this side, I will get to see two faces. Face A, which is of the top portion, and face B, which is of the part which comes in the bottom. Now both the cross section will look exactly the same. This is the same face, and this in this case looks like a square. Perfect. Let's look at another example. In this case, a cylinder. Right, so this is a cylinder, and if I cut it from the middle, I get two cross section, one in the top portion, one in the bottom portion. And can you tell me what will the cross section look like? Yes, it'll look like a circle. Good. Similarly, if I cut this prism vertically along this line, what will I get? I'll get two faces, face one on this side and on the other side. The face will look like a triangle. Perfect. Similarly, if I cut this cuboid from the middle like this, like here we had cut it height wise. Here if I'm cutting it lengthwise, then I'll get again two faces. Each face would look like a rectangle. So since wherever I cut, if I cut it at this position or this position, the face that I get, the cross section that I get will be the same. Similarly, whether I cut it here or here in the cylinder, the face that I'll get will still be a circle. Similarly, if I cut this prism here or at any other place, the cross section that I'll get will be a triangle. All these cross sections are known as uniform cross section, which means they remain the same wherever you cut from. So they have shown it in this diagram as well. When you cut it, the cross section that you get is a circle. When you cut it vertically along a cylinder, the cross section that you will get will be a rectangle. Perfect. Now let's look at a non-uniform cross section. A non-uniform cross section is, let's look at this prism in this form. So if I cut the prism here, I get a rectangle which is here, which is a bigger size. If I cut this here, I will get a smaller rectangle. If I cut this here, I will get an even bigger rectangle. So these are non-uniform cross sections. Similarly, this is a non-uniform cross section because if I cut it at this edge, the face of the rectangle will change. So these are uniform cross sections where the face remains the same, and this is a non-uniform cross section. So in this chapter, we will deal with uniform cross section. That's basically what we'll work with in this chapter or in this exercise. Let's go ahead and see a new formula that we need to do for this exercise. So volume of a figure is equal to area of its cross section into length. That's what it means. So if I again go back to the previous photograph, if I look at this, if I find the area of this cross section and multiply it with its height, because I've cut it in this manner, then area of cross section multiplied with the height will give me the volume of the total object. In this case, if I take the area of this cross section and I multiply it with its length, so I'm using height and length interchangeably depending upon which is the third dimension that you're looking at. In this case, I am cutting it along this line, which means what I need to take is the height. In this case, I am cutting from here, which means I need to take the length, whichever way you look at it. So this is the area, and then we talk about the next one. The next one which we'll have will be, so this is volume. Volume is equal to area of cross section multiplied with the length and interchangeably used with the height, whichever way you look at it. Next, surface area, which is surface area excluding the cross section of the three-dimensional solid, will be equal to perimeter of the cross section multiplied with the length. So this is the surface area of the cross section. And in case, let's say you have examples of water coming out of a circular or cylindrical pipe, or water coming out of some other pipe, petrol is being filled through a hose pipe. How long will it take? What's the speed of water? In that case, the formula that we use is volume of water flowing in unit time is equal to area of cross section multiplied with speed of flow of water, which means if this is a circular tube from which water is flowing out, then this will depend on the area of cross section. So area of cross section multiplied with the speed of flow. This will give me the water which will flow out in unit time, or any liquid which will flow out in unit time. Let's solve some questions and see how this works. So I am on question number 1. It says it has a diagram. This is as a uniform cross section. All angles are 90 degrees. We need to find the volume of the solid, and all these are in centimeters. So we've done these kind of questions in 2 dimensions when we were in 7th standard and 8th standard, where we needed to find the area of these. This time we need to find the volume. So let me draw a line here and divide this into 2 different solids. The first one would be this one, and the second solid would be this cuboid, which is lying horizontally, and this one is lying vertically. So let's call this cuboid 1, let's call this cuboid 2. So volume of cuboid 1 will be equal to the length into breadth into height. In this case, the height is 9, the breadth here is 3, or the length here is 3, and how deep it is, that's 4. So that's 9 into 3, 27, 27 into 4, that's 80, and 108. So that's 108 square centimeter. Let's look at volume of cuboid 2. That would be again length into breadth into height. In this case, the length is 6, the height is 3, and how deep it is 4 centimeter deep. So that's 6 into 3, 18, 18 into 4, that's 72 square centimeter. Therefore total volume would be equal to 108 plus 72 square centimeter. That's 72, that's 180 square centimeter. Done. Let's look at the next question. Next question, an extremely interesting and important question for this exercise. Let's look at it. The question says a swimming pool is 40 meter long and 15 meter wide. So this is 40 meter long, and if you imagine the third dimension, which is somewhere here, this is 15 meter wide, which means this is the cross section, and this will go in, if you look at it from one side, which means there is water filled in here right now, and I am standing inside the water, and I am looking at this at the swimming pool. Shallow end is 1.5 meter deep, which means this is 1.5 meter deep, and the deep end is 3 meter deep. 3 meter. Why have I written 15? This is 3 meter. My mistake. This is 3 meter, not 15. And so this is 3 meter deep. So shallow end is 1.5 meter deep, deep end is 3 meter deep. Bottom of pool slopes uniformly, which is what has been shown. Find amount of water in liters required to fill the pool, which means I need to find the volume of this. So again, I notice this is a uniform cross section, and the figure that I get is, let's call it A, B, C and D. A, B, C, D is in the shape of a trapezium since AB is parallel to CD. So since AB parallel to CD, therefore ABCD is a trapezium. Perfect. So volume will be equal to area of cross section multiplied with, in this case, the depth, which is 15 meter, into wide or depth, whichever you call it. So into depth. Let me use the word width because they have used the word width, because depth can be confused with how deep it is. So let me just use the word width. Perfect. So let's find the area of cross section. So area of trapezium ABCD will be given by the formula half into sum of parallel sides multiplied with distance between parallel sides. Yeah, distance between parallel sides, also known as the height of this trapezium. So in this case, this is 1 by 2 multiplied with 1.5 plus 3 multiplied with 40. This is 1 to 20. So this is 20 into 4.5 square meter, which is 80, and 10, that's 90 square meter. Therefore, volume would be equal to area of cross section, that's 90 square meter, into width, which is 15 meter. So 15 into 9, that's 135. So this will be 1350 meter cube. Next, they want the answer in liters. So we need to convert meter cube into liter. Just want you to remember, in case you've forgotten, 1 meter cube is equal to 1000 liter. There is one more conversion that we'll need in this chapter, which is 1 liter is equal to 1000 centimeter cube. So just remember these two conversions, life will be easy. So this is 1 meter cube is equal to 1000 liter. Therefore, this would be equal to 1350 into 1000 liters, which would be 1350 with 3 more zeros, liters. Right, so 13,50,000 liters, that's the answer. A very interesting question. Let's look at this once again. I know the volume would be equal to area of cross section into width. So first I figured out the area of cross section, which is nothing but area of trapezium, and then I use the formula to calculate the volume of water here. Good, let's look at the next question. The next question that we do is question number 3. So question number 3 says cross section of a tunnel perpendicular to its length is a trapezium ABCD, which means AB is parallel to CD. Good. AM is equal to BN, which means AM and BN are equal. AB is equal to 7 meter, which means the whole length here is 7 meter. CD is equal to 5 meter. CD is 5 meter, which means MN is also 5 meter. Good. Height is 2.4 meter, which means DM and CN both are 2.4 meter. This is 40 meter long, which means this is the entrance of the tunnel that we are looking at, which means it is going deep inside for 40 more meter, which means it's going in deep. This is the roof. It will keep going in, and this is the base or the floor. It will keep going in for 40 meter. Calculate the cost of painting internal surface of the tunnel, excluding the floor, which means we are looking at total surface area minus area of floor. That's what we need to calculate. Yes. So at the rate of something. So first let's figure out the area, and once we figure out the area, we should be able to calculate the cost. So we will be able to prove triangle ADN and CNB congruent, which means AM and BN in any case are equal. So this is 5, this is 1 meter, and this is 1 meter. Even if we don't prove congruency, this is 5, both of them are equal. If so, the remaining is 1 and 1. That's done. Next, in triangle ADM, let's just first write that because okay. So number 1, MN is equal to CD is equal to 5 meter, which means AM is equal to BN is equal to 7 minus 5 upon 2 meter, which means both of them are equal to 1 meter. Next, we need to find the cross-sectional area. For that, I'll need to know the length of AD. Okay, because for that I'll need the I'll need the cross section area. Perfect. So in a right triangle ADM using Pythagoras theorem, I get AD square is equal to AM square plus DM square, which means 1 square plus 2.4 square, which means 1 plus 2.4 into 2.4, that's 5.76. Yeah, 576, that's fine, which means AD is equal to 6.76. This is meter, and this is 2.6 meter. So I know AD is equal to 2.6 meter, and since these two triangles are exactly the same, which means this is also 1 and this is 2.4, which means therefore CB is equal to AD is equal to 2.6 meter. Now that we've done this, let's see what we need to calculate. So I need to find the surface area, which means let me first calculate the perimeter. So perimeter of cross section would be equal to, this is 2.6, this is also 2.6, so it will be equal to 2.6 plus 5 plus 2.6 plus 7. Let's just check. 2.6 plus 5 plus 2.6 plus 7. Perfect. This is perimeter would be equal to 5.2, 10.2, that's 17.2 meter. Perfect. Which means area of, what's this? This is tunnel. Area of tunnel without floor would be equal to perimeter of cross section multiplied with the length minus area of flow. Done. So this is from the formula that I talked about earlier. This is perimeter into length, and from there we need to remove the area of the flow. So perimeter is 17.2 multiplied with the length, which is given as 40. Subtract what area of floor. So the area is length into breadth, in this case 40 multiplied with 7, which means 40 times 17.2 minus 7, common, something is common, 40 is common, which means 40 multiplied with 10.2, which is 4 into 102, which is 408 square meter. Okay, so this is the area of the tunnel which needs to be painted. Let's do the costing now. This is simple. 1 square meter costs rupees 5. Therefore, 408 square meter will cost rupees 5 into 408, which is rupees 2040. Yes, it will cost rupees 2040. I still have one more part of the question remaining. So let me just open a new page, or let me just open a new page, or maybe I can I've already opened a new page. So let's look at the second part of the question. In that question we had we need to find the cost of paving the floor. So cost of paving the floor at the rate of rupees 18 per meter square. That's the question, right? So area of floor is equal to length into breadth. In this case it was 40 multiplied by 7 square meter. 1 meter square costs rupees 18. Therefore 40 into 7 meter square will cost rupees 18 into 7 into 40, which is 280 into 18. Let's do the calculation. 8 into 8, that's 64. 16 plus 6, 22. That's 8 and 2. That is 405 and with a 0. So this is rupees 5040. 40. Perfect. So that brings me to an end of this video. I will see you with the next video. Take care. Be safe. Bye bye.